Look around you, the blades of a pair of scissors opening, the hands sweeping across a wall clock, the tilt of your laptop screen. These are all practical applications of the same geometric principles. Mastering lines and angles provides the technical foundation for analyzing and constructing more complex shapes. Geometry functions much like architecture. You cannot support a roof without first laying the bricks. To understand how shapes are built, we have to start with the most basic elements. The most fundamental unit is a point. Imagine the very tip of a sharp needle. A point determines a precise location, but it has no length, breadth, or height. If we mark a second point and draw the shortest path between them, we get a line segment. It has a distinct starting point and a distinct ending point. We denote this by writing a bar over the two letters, A and B. If that segment is extended forever in both directions, it becomes a line. In our diagrams and notation, we add arrows to both ends to indicate that it never stops. Then there is the ray. This is a portion of a line that starts at one fixed point, like the bulb of a lighthouse, and goes on endlessly in a single direction. One side is a hard endpoint, the other is an arrow. These three elements, the segment, the line, and the ray, form the vocabulary of geometry. Identifying them correctly is the first step towards defining and measuring any geometric figure. An angle is formed when two rays share a common starting point. The common starting point is called the vertex, and the two rays are referred to as the arms of the angle. An angle's size isn't determined by line length, but by the rotation required to move the first ray to the second. You see this in scissors or a compass. The angle changes as the arms move apart, regardless of how long the blades are. Because the vertex is the center of this rotation, there is a specific rule for naming angles. The letter representing the vertex must always be written in the middle. This is angle ABC, or angle CBA. It is never angle BAC. Focusing on the amount of turn and keeping the vertex in the middle avoids the most frequent errors on geometry assignments. To quantify rotation, we use degrees. A full circular turn is 360 degrees. Half of that turn creates a 180-degree straight angle, looking like a flat line. A quarter turn creates a 90-degree right angle, the shape of an L. We use the 90-degree right angle as our reference boundary. An acute angle is sharper, measuring less than 90 degrees. An obtuse angle is blunter, measuring between 90 and 180 degrees. A protractor finds exact measures using two sets of markings. To choose between them, find where the bottom arm sits and start from that zero mark. Here, ray OP points right, aligning with the inner zero. Look at angle ROS. Ray OS passes 110 and 70. Since our baseline is the inner zero, we follow the inner scale to 70 degrees. You can verify your reading by looking at the shape. Angle ROS is an acute angle. Since acute angles must be less than 90 degrees, 70 is the only logically correct answer. When solving a geometry problem, you will typically need to perform three steps: name the vertex, classify the angle type, and state its degree measure. First, identify the corner point to find your vertex letter. Next, compare the opening to a right angle to determine if it is acute or obtuse. Finally, align your protractor center on the vertex and read the scale starting from 0. Here's a summary of our building blocks. Points, segments, lines, and rays define structure. Acute, right, obtuse, and straight angles define rotation. Now, look at the geometry in this bicycle frame. There are 4 specific angles marked here at the joints: A, B, C, and D. Based on their shapes, classify these 4 angles and post your answers in the comments. Identifying these correctly shows you can now decode the geometry in the world around you.